Hi everyone, I am Kishan. I have Jude and Samir here with me. Today we are going to present about the Google Knowledge Graph and how semantic web take a part of it. Also the issue people face with the technology and the future developments need to sort out them. Let's start with the bit of intro. What is Google Knowledge Graph in brief? It's a archived graph with more and more data. This graph has more details, contains truth, intelligence and semantic. Most importantly, they are captured from the real world about the people, place, and business, etc. The trick here is the information captured by the graph can be searched in the meaningful way. This is the semantic principle behind the Google Knowledge Graph. Organizing the information in the structured way by the explicit describing the relation among the entities. Now such tags are not only string. It recognizes as entities. Entities can be of many types, which we can discuss this later. Then it may identify all the related entities and they can be connected with each other. As you can see in the picture, each relationship has tag 2. In a nutshell, so we can now say Google recognize things, not string. And by things we mean an entity. Knowledge graph is generally described as a being made up of entities, but the Google tend to refer to entities as a topic in its public documentation. Any entity is generally given a topic type. It may be a person, organization, event, place, or country. If it is none of these, it is usually simply labeled as a thing, although the entity type might continue to be developed by Google. Google's natural language processing API gives clues to suggest that many entities types are being used, such as the work of art and consumer goods. Let's quickly go through with a bit about history. Google announced its knowledge graph on May 16, 2012. There are many knowledge graphs in the world. The Google knowledge graph is just one. Other includes the dppedia.com, wikidata.org, etc. Google is known to have built out its knowledge graph initially from other datasets including Wikipedia and the CIA Factbook. A knowledge graph is generally described as a being made up of entities, but the Google tends to refer to entities as a topic in its public documentation. This is how a part of Google Knowledge Graph may look like. As you can notice, each entity or topic is shown as node and is linked to other related entities. If we focus on the Star Wars node here, we can see its character was played by the actor Harrison Ford, who also appeared in another movie called The Blade Runner. Take a note of this particular section of the graph. We will demonstrate to you later how Google actually takes into account this data is displaying in search result. Let's see where Google Knowledge Graph is being used. The first place we can think of is in the Google search engine. People don't always search by the exact string. They describe things in a different ways. For example, take the query. Small green guy with lightsaber. That's where the knowledge graph comes in, as it allows Google to go beyond keyword matching and return more relevant result. Despite the fact we didn't even mention the Star Wars, Google still understands what we are looking for and gives the answer. The same is true for the query Han Solo actor other movies. Here not only are the results relevant, but Google also shows the connection in the knowledge graph and provides an entity crucial which satisfies our query. If you remember the slide of the Google knowledge graph I explained earlier, you can see Han Solo is the actor of both Star Wars and the Blade Runner. Let's see how SEO works then and now. Before the Google Knowledge Graph invented, major portion of the search engine optimization was based on the usage of repetitive primary keywords. Now it's intelligent use of primary and secondary keyword, user experience and uniqueness and depth of content. With the Google Assistant now built into more than 1 billion devices and around the 70% of requests being expressed in the natural language, making sense of voice query is more important than ever for Google. How does the Google Knowledge Graph help with this? It allows Google to recognize the entities and attributes in the natural language queries. Just think for the moment about the way you type search queries versus how you actually talk. Yes, there is a difference. Take a look at the query for example. I have already explained this earlier too, because Han Solo and the Star Wars are closely connected entities in the knowledge graph. It's easy for the Google to pull the answer you are looking for. Google also take your most recent search into account for the voice search. If you ask which actor play Han Solo in the Star Wars, and then how old he is. Google will also know that he is referring to the Harrison Ford. Let's see where else we use the Google Knowledge Graph. Google use information about your behavior to understand what topics are important to you and can surface related topic based on user history. Android smartphone users, the most prevalent use of the knowledge graph is in fact in the discover feature on their home screen each day. We can see the relevant topics in the Google Trends. Now I'm handing over to my colleague Samir and he will continue with the next section.
Thanks, Kishan. Now I'm going to talk about how Google Knowledge Graph works. So to construct a Google Knowledge Graph, a process called information extraction is used. During this process, semi-structured and or unstructured language is read and translated along with an ontology, which is a description of things, their relationships and their properties. The process of information extraction includes named entity recognition, which are used to identify and divide the named entities and categorize these entities in predefined classes. Relation extraction, used to identify the semantic relationships, and even extraction, determines what happened and when it happened. The next step in constructing knowledge graph is entity resolution, which entails linking entities in data to real world data. The two important things in Google Knowledge Graphs are ontologies and resource description frameworks, or RDF. So ontologies define the type of things, that is, their relationship to the other things and the properties applicable to those things. The Resource Description Framework (RDF) is a general framework for representing interconnected data on the web. RDF statements are used for describing and exchanging metadata, which enables standardized exchange of data based on relationships. RDF also utilizes the triples data model, which corresponds to the internationalized resource identifiers (IRI), which are very similar to the URI or URL but permit Unicode characters, whereas URL will resolve to a particular web address and IRI may not resolve to anything. So a URI in a Google Graph may look like this, and this is how labels and basic relationships are used in the Google Knowledge Graph, and this forms the backbone of the Google Knowledge Graph. Then more details are added by specifying relations and classes using ontologies, which give knowledge graphs an additional dimensionality. Then Google Knowledge Graph adds metadata and graph annotations, like for example opening hours, which enriches the user experience. Furthermore, Google brings structured, unstructured enterprise data into the knowledge graph. And finally, Google gathers all the data about you as a user and puts it inside the graph to give you more personalized and contextualized experience, and ultimately which leads to the better search results. In this and next few slides, I'm going to demonstrate how we can use RDF provided by Google Knowledge Graph API with SparkQL and Turtle. So you can open the link which is highlighted on the screen, and on this page you will be able to see how we can get started with Google's Knowledge Graph API. This page demonstrates what you can put into the URL to request the JSON LD data from their knowledge graph. The first example sends a search for the query Taylor Swift. This request returns response in JSON-like structure. We have used this example with curl and Gina write command line tool to get the turtle triplets from the Google Graph API. So if we run the following command highlighted on the screen, we'll be able to see the result in turtle format. The command returns 14 triplets, which you can see in the screen. You can also configure the query parameters of the URL, whose explanations are displayed on screen. Unfortunately, Google Knowledge Graph API doesn't return large amounts of data for each entity, as it uses different sources to gather that data. But it gives us Freebase ID, which we can use to drive additional information from Wikidata. From the response we got earlier, we can clearly see that the local name of the URI used to represent Taylor Swift as a resource in the Google Knowledge Graph is M0DI567. Also, if we check the Wikidata page of the Taylor Swift, it has the same ID, which I stated earlier. So Wikidata gives us Wikidata Query Service, where we can execute some SparkQL queries to get some additional information about our search queries manually. So let's try to link the RDF returned from the Google Knowledge Graph with SparkQL using Wikidata Query Service. So we are constructing a SparkQL from Taylor Swift's ID, which we got from the Google Knowledge Graph API response. So the query looks something like this. Construct subject predicate object where subject has this ID, predicate and object can be anything. And after executing this query, it gives us a result which has about 1224 items. We can also try another example with prefix equal to true query param. If we execute a curl query to Knowledge Graph API which asks for all entities of types music group and whose name begins with BEA, and after we execute the query we will get 481 results which include the Beatles, Beach Boys and Beasties because all of these start with BEA. We can then use SparkQL query to sort the results and the query is shown on your screen. And here are the first few results when running this query against RDF or BEA music groups that the curl command above pulled down. It's quite interesting to be able to get the type data directly from Google's knowledge graph, especially since we can connect much of that data to the other useful data resource. Now my friend Jude is going to talk about open issues with the Google Knowledge Graphs.
Thank you, Samir. Hi, I'll walk you towards the most common issues with Google Knowledge Graphs and what future development we may await. Let us first look at the open issues and go through them one by one. First issue: difficulties of knowledge you speak. Unfortunately, there is yet no general method for text comprehension. In other terms, there is no universal algorithms process all the text in the world. Current algorithms have pretty hard time interpreting the intended meaning behind the words, as it is given in the example. If we take this sentence, I saw a man on a hill with a telescope. The semantic triple might interpret it as, there is a man on a hill and I'm watching him with my telescope. Oh, there is a man on a hill who I am seeing, he has a telescope. See the difference of this interpretation. First sentence says, I am having a telescope, and second says, the man has it. Look at the fourth sentence. It has a whole different meaning. It says, I am on a hill. Likewise, we often see so many misinterpretations of Google search results through knowledge graph. Various cultures use their words and phrases differently. So, without a universal algorithm, Google Knowledge Graph cannot guarantee that it will always process the relevant information. Second issue: processing new data in machine learning. This means new data which learning algorithms not trained yet. When processing them, Google Knowledge Graph cannot guarantee their accuracy. Instead, it might result in a completely different outcome. There are just a few examples how things have gone wrong in past. First illustrates when the term gorilla was searched, Google Images showed pictures of a black couple. Second and third are the Google recommendation for "Are Muslim bad" and "Are women evil?" Google apologized to the affected parties and corrected those issues in their algorithms. However, no one can assure that Google Knowledge Graphs would make similar types of errors in future. The next issue is misleading intelligent systems. This means that intelligent systems are being trained using world's present and past data. But nobody knows what would happen in future. As intelligent systems access current or historical data, but a change occurs at some point in time, Google Knowledge Graphs will deliver completely irrelevant results to the end users. According to the given example, Google returns photos of men for the search keyword of CEO. This is due to the gender bias, because mostly males have held this role in present and past. But what if more women started to become CEOs in future? There are similar examples for misleading and intelligent systems, which is a big issue in Google Knowledge Graph. Another issue is the suffers from human bias. This happens when Google Knowledge Graphs trust on sources that are controlled by humans. Google trust in Wikipedia contents is one of the perfect examples for this. We know how popular Wikipedia is. Even though it is open for anyone, the authors edit Wikipedia pages are not normal. They are certainly not representative of society. Those who are hired to be independent are specialists in ontologies and encyclopedias. Even if ordinary people attempt to submit material, it will be examined further by high-ranked members in Wikipedia, which means the ultimate control lies in the hands of few people, and Google Knowledge Graph treat those contents as genuine and publish in their results. This might help those parties for some political gains. There is a saying, you could hold power if you hold all the cards. The last set of slides will discuss potential future developments connected to Google Knowledge Graphs. The first development listed is empowering machine learning related to Google Knowledge Graph to consider wealth of cultural facts. This could be a great development as it can know all the culture behind the things users bring to the search box to produce relevant results. As per the example, while to be or not to be may seem like a well-known statement from Shakespeare to you, someone unfamiliar with his work may see it as nothing more than a strange collection of words. Next, complex reasoning. Google should think of combining logic rules and semantic similarity in order to take advantage of logic rules and deal with their uncertainty. Finding methods to effectively incorporate domain knowledge and uncertainty in predictive findings will be a promising research path. Last in my list is developing a unified framework. This means currently there are many findings. We need to put them all together to develop a general framework. These are some well-known findings. Bayesian Schimper proved whole and complex are mathematically equivalent. Analogy provides a joint view of dismalt, complex, and whole models. Connections between several geometric models explored by Wang. Sharma studied the geometric understanding of additive and multiplicative KRL models. Most work made separate models for knowledge acquisition and relation extraction. Future studies should lead into how to put them all in one framework. Well, that's conclude our presentation about Google Knowledge Graph. Thanks for watching.